Hi everyone, welcome back to Lifey Technologies YouTube channel and thank you for watching. So if you remember in our last episode we discussed how to implement the IndaAS BGP MPLS VPN IPVPN option A, and we explained that option A is VRF to VRF peering. So we have back-to-back VRF peering BGP session between the ASBR. So we have already implemented the option A, and now we need to understand how the traffic will be flowing in our network. So this is what we'll be covering in this session, just to try and analyze how traffic is flowing on our network. Remember, we haven't configured MPLS between the SBR. So on the SBR, we're expecting that when one SBR is forwarding traffic to another SBR, we just have IPv4 routing. No labels should be exchanged between the SBRs. So this is the topology that we have been working on. We have AS200, we have AS100. In AS100, we are using OSPF as our IGP. In AS200, we are using SIS as our IGP. And then we need to configure BGP peering sessions between different nodes. We have BGP peering session between P1 and SBR1. We also have BGP peering session between SBR2 and P2. For the PEC protocol, we are also using BGP, so we are configuring BGP peering sessions between PEs and the CEs. For our option A implementation, we are doing it between SBR1 and SBR2. So we have two VRFs. We have VRF1 that we are configuring customer 1 and customer 2 in VRF1. And then we have the second VRF, VRF2. That is for customer 3 and customer 4. That is C3 and C4. So remember, as I've mentioned in our last episode, we need to ensure that we have communication between these customers. So customers in VRF1 should be able to communicate, and customers in VRF2 should also be able to communicate. So we can just start by verifying that our protocols are running okay. So on this router, I can display BGP, VPN, V4, all peering. So we have 3 peering sessions. We have one to the SBR, and we also have peering to C3 and C1. I can also display the peering session on SBR, display BGP, VPN, V4, all peering. So we have 3 peering sessions to PE and then to the SBR. So we have a peering session established for every VRF towards the peer SBR. On SBR2, we also expect the same, display BGP, VPN, V4, all peering session. So you can see that we also have 3 sessions, one to P2 and the sessions between the ASBRs. On P2, we can also verify that our peering session is up, display BGP, VPN, V4, all peer. We also have 3 peering sessions, one to the SBR and 2 peering sessions towards the customers. So that means that our PEC protocol is okay. Display BGP peer. You can see that we have a session to P2. So we have already configured all these protocols, OSPF, SIS, so we have connectivity within the autonomous system. We have also implemented BGP to ensure that we have connectivity between different autonomous systems using option A, as mentioned before. So how does traffic flow? Remember, before I show you that we need, if I display IP routing table, we have learned the IP addresses coming from the remote CEs. So we have the routes. We can be able to ping, and we need to source 1.1.1. We can ping 8.8.8. So we are able to communicate from C1 to C2. C3 can also communicate with C4, which means there is no point of disconnect in this network. So how does the traffic flow? Remember, we are using labels, but between SBR1 and SBR2, we don't have labels assigned. We are just using the normal IPv4. So that is one challenge with option A. We don't have an end-to-end LSP. So with other options, we can be able to establish an end-to-end LSP from our local PE to the remote PE, but with option A, we don't have an end-to-end LSP. So we have an LSP from P1 to SBR1, and we also have an LSP from SBR2 to P2. So when we are changing the labels, it means we will have to change the inner label. Remember, with MPLS IPVPN, we have the inner and outer label. So we have one inner label assigned by P1 and the outer label that is shared for that prefix. But when the packet reaches to SBR, they are forwarded as IPv4. No labels are assigned on those labels. So we have to drop all the labels on SBR1. So how does the traffic flow? The first step that we need to understand is that from C1, we are getting an IP packet. So I can illustrate this with this diagram. We are getting an IP packet from C1. When the packet arrives on P1, we need to remember P1 is in our MPLS domain. So now the label that came in as an IP packet is converted to an MPLS packet. P1 will push a label on top of the IP packet. And it does this by adding two labels. So it will add the inner label and an outer label on top of it. So this is an MPLS packet. It's forwarded to P1. P1 also is in our MPLS domain. So it has to perform the swap operation. But remember, this is the penultimate hop. So it doesn't have to add the label when it's forwarding the outer label. The outer label is not added because this is a penultimate hop. So it will drop the outer label and forward the MPLS packet with the inner label to our SBR1. SBR1 will pop all the labels. So it removes the label that it received from P1, and then it will forward the packet as an IP packet to SBR2. So when the packet arrives to SBR2, it's now an IP packet, but remember, it's coming in from the PE. So remember, we mentioned that the SBR see each other as PECE. So SBR2 will again push a label on top of the packet, the inner and outer label, and forward the packet to P router, the provider router 2. So provider router 2 also performs the swap operation, or in this case it's the penultimate hop, so it can remove the outer label and just forward the inner label to PE2. So PE2 receives an MPLS packet. It has to remove the label. It will pop the label and forward the IP packet to C2. So to illustrate this, we will be doing packet capture on the network, and we should be able to see how these labels are moving. So we'll start with C1 to P1. So from C1, we can capture packets on this interface. So I will start a capture, and then I will do a ping from C1 to C2. I will just filter ICMP packets. So I only need to capture the ICMP packets. So on C1, I will do a ping. So when I'm doing the ping, we are capturing the packets. And you can see that this packet, they are all just normal IP packets. We don't have any labels assigned on these after our internet, the IP packet, in our IP packet. So we are only forwarding IP packet from C1 to C2. And you can see all the detail, the source and the destination, and many other fields that you can see when you do the packet capture. So it's always a good practice when you are doing lab simulations. You can always capture packets and try to analyze which information is being carried in these packets. So this one verifies that we are only sending an IP packet from C1 to P1. But now when a packet arrives to, I will stop the capture and start it again so that we see the second part. So remember, when I go back to my diagram, we have received an IP packet from C1. So the next step is we need to push some labels on the IP packet that we have received from C1, and then we'll be forwarding these in our MPLS domain. So on C1, I will do another, on P1, I will do another packet capture. I'll do a packet capture on this interface. So I will start a packet capture and then we can do another ping just to verify that we are having two levels of label. So we have label stacking. We will add two layers of label, the inner label and the outer label. So we are capturing the packet. The next step is to do another ping. So I will do a ping from C1 to C2. So with this ping, we can observe the labels, we can observe the packets. So you can see that now, when we do a request, the request is coming in with two labels. So we have the outer label. You see that the outer label is 1030. Experimental field is set to 0, bottom of stack is set to 0. Remember, this is not the last label. We have an inner label. And then the TTL is set to 255. So you can see that our MPLS label is 1030, the MPLS experimental bits, the bottom of stack, and the TTL. So these are the four fields of an MPLS packet. So this is our outer label. From there, we have the inner label. And we need to remember this 1038 because when we do a capture on the other side of P1, we need to have this 1038 as the only label that is available. So with the inner label, you can see that we have the MPLS bottom of label of stack set to 1 because this is the last label. So the bottom of label stack is set to 1. And then we have the MPLS label 1038 and the experimental field is still set to 0. So this one verify that we have label stacking. We have two labels that have been stacked from P1. It has added two labels, one inner label and an outer label. So outer label is just to forward the traffic from P1 to SBR1, but now the inner label will be used to identify the customer on the end device. So this one verify that we have two labels. We have the inner label and the outer label. So the next step is now to verify. I'll go back to our diagram. We'll now verify when the packet is coming from P1 to SBR1. How does it look like? So for this, we also need to do a packet capture. So I will do a packet capture. I will stop the current packet capture just so that we don't overuse the resources. So I will now do a packet capture here. I will start another packet capture. And we need to do a ping just to verify that we only have one label that is coming in from the penultimate hop, the inner label. And remember it was 1038, so we expect to have the same label, inner label that is coming in from. So remember we had 1030 and 1038 from P1. So the packet has gone to P router and then it's now going to the SBR. So which labels do we have? So we have the packet capture running. We can do another ping. So when I do a ping, we observe that we have this inner label. So we still have the inner label intact, and then the MPLS bottom of stack is still set to 1. Remember, this is the last label, the inner label that we have on the packet. So we don't have the outer label. It has been dropped already because that is the penultimate hop. So it has removed the outer label and just remain with the inner label that is now forwarded to the SBR to determine the customer. So once the packet is on the SBR, we have said that from the SBR we are just using IPv4, so we don't need any label between SBR1 and SBR2. So what I'll do is I will start another capture between SBR1 and SBR2, and then we can do a ping just to verify that we don't have any label information because we haven't configured MPLS on that interface. So with my packet capture running, I can do another ping, but I'll filter ICMP because we only need the ICMP packets. This one helps us to minimize the number of packets that we are capturing. We filter. So I will do another ping. So when the ping is going through, you can see that we have packets. And this one just only has the 8.2.1q VLAN tag. So we don't have any labels on this packet. It's just a normal IPv4 packet that is being exchanged between the ASBR and the ASBR01 and ASBR02. Same, you can see same for request and reply. We don't have any labels assigned on the packet. So this is the main key feature of option A. We are not forwarding MPLS packets between the ASBR. We just use the normal IPv4. So this one we have verified that we don't have any label. So I will stop it and then we can do another capture. So when the packet arrives on the ASBR2, remember ASBR2 is now acting as the PE. So it also has to add 2 labels on the packet and forward the packet to P2. P2 will perform similar operation. It will pop the outer label because it is the penultimate hop, and then just forward the packet with the inner label to P2. So P2 ASBR2 will assign labels. Let's see, 2 labels. So I will start another ping from now. I need to do the filter, but we can see from our echo requests and reply packets, we can see that from this packet we have 2 labels again, and the inner label has changed. It's not same as the one that we received from the P1, the provider edge router 1. So the label has changed. This is the reason why we don't have an end-to-end LSP. We have segments. So we have an LSP from ASBR1 to P1, and we have another one from ASBR2 to P2. So this one we have assigned 2 labels again. We have the outer label 1026 and an inner label of 1050. So we expect the same label, the inner label should be able to be captured from the other end. So this is it for this capture. You can see that we have 2 labels. So the next step is now to capture packets when they are being sent to P2. So on P2 we can do the packet capture. I'll filter the ICMP just to minimize the number of packets that we are having on our. So with this, I will do another ping. Then we can observe the packet information. You see that the outer label was the inner label was 1050. Now we don't have the outer label. The outer label has been removed by the penultimate hop router. And then we only have the inner label that is forwarded to our PE router. So the PE router will perform the pop operation, and then it will forward an IPv4 packet to the CE. So at this stage, we can do a final Wireshark capture on. I need to stop this one. I'll stop the capture, and then our final capture we can do on this interface. So I will filter ICMP again, and then I can do another ping. So when we do another ping, you can see that this is just a normal IPv4 packet. We don't have any label information attached on the packet. So this one verifies that we have, if I just go back to our diagram, that we have an IP packet coming in from the CE. When it reaches the PE, we attach 2 labels. We push. The right word is to push. We push 2 labels, the inner and the outer label. When the packet arrives to P1, P1 will pop the outer label, and keep the inner label. Remember, the inner label is the one that identifies the customer on the far end. So we need to keep the inner label. But if we have multiple routers in the middle, then we need to perform the swap operation. That one we can verify later. So the MPLS packet is forwarded to P1. P1 pops the outer label, remains with the inner label, and the MPLS packet is forwarded to SBR. The SBR will perform a pop operation and remove the inner label and forward the IP packet to SBR2. So SBR2 will also do a push operation and add two MPLS labels. So it will forward it as an MPLS packet with two labels, the inner label and the outer label. You saw that it was 1050. And then from P2, we have the pop operation again. We need to remove the outer label and just remain with the inner label. So the inner label is forwarded to P2. And P2 will pop the inner label and now forward the packet to our CE. So of course the labels will change. If we were to do a ping from C2 to C4, I mean C3 to C4, the labels will change. So this just verified that our packet flow has the MPLS labeling information, and between the SBR we don't have packets, so we don't have MPLS labels on the packets. So one other thing that we need to verify is if you miss to configure MPLS or LDP on any of these interfaces. So I will just do a continuous ping. From here I will ping 100 packets. So if you are to miss on configuring these interfaces, maybe let me see interface gig 0/0/0. We know that we have MPLS and MPLS LDP configured. If I remove undo MPLS LDP, let's see our ping if it's still going through. So you see that we are already losing the packets because we don't have labels. Remember, this is MPLS domain, so we are only depending on the labels to forward the information. So we'll have a route on C1, but we don't have the label. So if I just display, let's display the IP routing table. We don't have the route because we have lost the label information. The route is not reachable, so it will not be advertised towards the CE. So what we can do is we can reconfigure this one and just I'll continue my ping again, and on P1 I can do the MPLS LDP command. So once we do that, we expect that from C1 we are now able to ping again from C1 to C2. So this shows the importance of having MPLS, and if you were to miss it on even a single interface, you end up having this connection between the PEs. So this is it, guys. Thank you for watching, and yeah, if you have any question, feel free to reach out. If you need the lab simulation, the script and the topology setup, just feel free to reach out to me on LinkedIn, and then I'll be able to share the configuration file and the topology. Thank you again, and please remember to subscribe to our channel. Bye.